Hello, science fans. Welcome to a journey into one of the most fascinating and powerful forces shaping our planet's weather, the polar vortex. Whether you're bundled up in a snowy city or watching from a warmer place, the story of the Arctic whirlwind affects us all. Today, let's dive into the polar vortex, a massive spinning top of cold air that hovers high above the North Pole. Imagine a gigantic icy cyclone swirling relentlessly, shaping the weather not just in the Arctic, but across the entire northern hemisphere. This swirling system acts like a barrier, keeping the coldest air locked in the Arctic and away from more temperate regions. It's a crucial part of our climate system, helping to maintain the balance between the frigid north and the milder south. But as our climate changes, this ancient system is showing signs of strain. Rising global temperatures are causing the polar vortex to weaken and wobble, sometimes sending blasts of Arctic air much farther south than usual. The stability of the polar vortex is crucial for predictable weather. When it's disrupted, we can experience sudden severe cold snaps and intense winter storms in places that aren't used to such extremes. These changes don't just mean colder winters, they can also impact our daily lives, from how we dress and travel, to how we heat our homes and protect our communities. Understanding these shifts helps us prepare for whatever the weather brings. Scientists and meteorologists are working hard to study the polar vortex, using advanced technology and on-the-ground research to track its movements and predict its impacts. Their work is vital for keeping us informed and safe. By the end of this chapter, you'll see just how interconnected our planet's systems truly are. The polar vortex is just one piece of a much larger puzzle that links the Arctic to the rest of the world. So let's get started and take a closer look at the evidence. Together, we'll uncover the science behind the headlines and discover what the future might hold. Science empowers us to make informed decisions, adapt to changes, and protect our communities. Let's explore the Arctic whirlwind and see what it can teach us about our changing world. Imagine a gigantic, spinning pool of cold air high above the North Pole, swirling relentlessly in the upper layers of our atmosphere. This isn't just any ordinary weather system, it's a powerful force that shapes winter weather across the entire northern hemisphere. The polar vortex resides in the stratosphere, a layer of the atmosphere that sits well above where most of our weather happens, and it's constantly in motion, circling the pole like a massive icy crown. This vortex is vast, stretching thousands of kilometers across, and within its core, temperatures can plummet to a bone-chilling minus 70 degrees Celsius. The air here is some of the coldest found anywhere on Earth, creating a frozen fortress that dominates the Arctic region. The landscape below is locked in ice and snow for much of the year, a testament to the vortex's frigid power. Encircling this cold air is the jet stream, a ribbon of high-speed winds that acts like a barrier, keeping the polar air trapped in the north. The jet stream is a dynamic, ever-shifting current that can reach speeds of over 300 kilometers per hour, and it plays a crucial role in maintaining the delicate balance between the Arctic and the rest of the world. When the polar vortex is strong and stable, the jet stream remains tight and well-defined, ensuring that much of North America and Europe experience relatively mild winters. Cities that might otherwise be buried in snow can enjoy more temperate conditions, all thanks to the invisible shield created by the vortex and its winds. The polar vortex itself spins counterclockwise over the North Pole, a motion driven by the Coriolis effect, the same force that causes hurricanes to rotate. This spinning motion helps to keep the cold air locked in place, swirling around the pole like a giant atmospheric whirlpool. This system is more than just a local phenomenon, it's a key player in global climate patterns. The polar vortex acts as a boundary, separating the icy polar air from the warmer air of the mid-latitudes. This separation is vital, as it helps regulate temperatures and weather patterns across continents, influencing everything from snowfall to windstorms. But the vortex isn't always stable. When it weakens, due to natural fluctuations or changes in atmospheric conditions, the jet stream can become wavy and distorted. This breakdown allows the cold Arctic air to escape its usual confines, spilling southward in dramatic fashion. When this happens, frigid air masses surge into regions unaccustomed to such cold, triggering sudden and severe cold snaps. These Arctic blasts can bring record-breaking low temperatures, heavy snowfall, and dangerous wind chills to cities far from the pole, catching many off guard. So, when meteorologists talk about a polar vortex event, They're describing a breakdown in the system that usually keeps the Arctic's coldest air contained. This disruption can have far-reaching impacts, affecting millions of people and altering weather patterns for weeks at a time. Understanding how the polar vortex works helps us better prepare for its impacts. Whether that means bundling up for a deep freeze, protecting infrastructure, or planning for energy needs during extreme cold. The polar vortex is a fascinating dance of pressure, temperature, and planetary motion, a reminder of how interconnected our world's weather systems truly are. As we continue, let's explore how this powerful force shapes the weather we experience every winter, and why understanding it is more important than ever in our changing climate. What could possibly disrupt a continent-sized whirlwind, a force of nature so immense it shapes the weather for half the planet? The answer lies not in something you can see, but in a dramatic shift high above the surface, an invisible battle between warmth and cold. Warmth, specifically a phenomenon known as sudden stratospheric warming, is the key disruptor. In a matter of days, temperatures in the stratosphere above the Arctic can soar by up to 50 degrees Fahrenheit, a change so rapid and intense it sends shockwaves through the atmosphere. This warmth doesn't arrive by chance. Powerful atmospheric waves generated by mountains and weather systems far to the south surge upward and carry energy into the stratosphere. As these waves break, much like ocean waves crashing on a beach, they deposit heat and momentum, rapidly increasing temperatures and disturbing the polar vortex's delicate balance. The result? The polar vortex, once a tight spinning ring of cold air, begins to weaken. Its walls become less defined, and the once stable circulation starts to wobble and falter, making it increasingly unstable. This instability is made worse by a process called Arctic amplification. As the Arctic warms faster than the rest of the planet, sea ice melts away, revealing dark ocean water that absorbs even more heat from the sun. This extra warmth feeds back into the atmosphere, further weakening the vortex. A warmer Arctic doesn't just mean less ice, it means the very structure of the polar vortex is threatened. The boundaries between cold and warm air blur, and the vortex loses its grip on the region. As the vortex weakens, the jet stream, our planet's high-altitude river of wind, also loses strength. It becomes wavy and erratic, no longer able to keep cold air locked in the north. Imagine a spinning top that starts to wobble and tilt. The polar vortex behaves the same way, stretching, distorting, and sometimes even splitting into two or more smaller vortices. When this happens, frigid Arctic air can escape its usual confines and plunge far to the south. Cities unaccustomed to severe winter weather can suddenly find themselves in the grip of snowstorms and bitter cold. At the same time, warm air from the south surges northward, bringing unseasonably mild conditions to places that should be frozen. This clash of extremes can lead to rapid snowmelt, flooding, and other weather surprises. The result is a world turned upside down, bitter cold in some regions, record warmth in others, and a patchwork of weather that defies expectations. By understanding how the polar vortex can be disrupted, scientists and meteorologists can better predict these wild swings in weather, helping communities prepare for whatever comes next. The polar vortex is just one part of a vast, interconnected system. Its behavior has ripple effects that can be felt across the globe, influencing everything from winter storms to heat waves. As we explore the impacts of a wobbling vortex, we begin to see how deeply it shapes the weather we experience every day, from blizzards to balmy spells. The stability of the polar vortex is more than a scientific curiosity. It's a crucial factor in the climate and weather patterns that affect us all. January 2014 made polar vortex a household term in North America. A sudden stratospheric warming event disrupted the vortex, unleashing Arctic air. Temperatures plunged to historic lows, with wind chills reaching dangerous levels. The cold was a direct threat to public safety, forcing people indoors. The economic impact was massive, with billions in losses and thousands of canceled flights. Infrastructure problems arose, like fragile ice-clogging water intakes. The event showed our vulnerability to extreme weather. It highlighted the connection between the polar vortex and our daily lives. The 2014 deep freeze was a powerful illustration of interconnected systems. Understanding this helps us prepare for future events. Let's explore how this affects our weather. The 2014 event wasn't unique. A weakened vortex affects the entire northern hemisphere. In 2018, Europe faced the beast from the east, with snow in unexpected places. Asia felt the impact in 2016, with extreme cold reaching subtropical Taiwan. These events show the global reach of the polar vortex's influence. In 2012, a cold wave hit Europe and North Africa, causing hundreds of deaths. The cold strained energy grids and emergency services. In 2021, Texas faced a catastrophic freeze with power grid failures. These events highlight the need for preparedness in unexpected regions. Understanding the polar vortex helps us anticipate its impacts. It's a global phenomenon with local consequences. Let's explore how this affects our weather. Arctic outbreaks pose serious health risks, like hypothermia and frostbite. Hypothermia occurs when body temperature drops dangerously low, leading to organ failure. Frostbite can cause permanent tissue damage and require amputation. Extreme cold also worsens respiratory and cardiovascular conditions. Vulnerable populations like the elderly and homeless face higher risks. Cold weather causes more deaths than heat waves, highlighting its public health impact. Understanding these risks helps us protect communities during polar vortex events. Forecasting polar vortex disruptions is complex but advancing. Weather balloons and LiDAR provide real-time atmospheric data. Satellites offer a global view, improving computer models. Supercomputers simulate future atmospheric states, extending forecast windows. These tools give us lead time to prepare for cold snaps. Understanding the polar vortex helps us anticipate its impacts. Let's explore how this affects our weather. How can a warming planet cause cold snaps? It's not a contradiction. A warming Arctic creates conditions for a weaker polar vortex. Global warming disrupts climate systems, leading to more extremes. Arctic amplification accelerates warming, destabilizing atmospheric patterns. Weather is short-term, climate is long-term trends. A warming planet leads to more extreme weather, including cold snaps. Understanding this helps us prepare for future events. The polar vortex's stability is crucial for our climate. Let's explore how this affects our weather. It's a complex, interconnected system with global consequences. Looking to 2035, we must adapt to a less stable polar vortex. Strengthening infrastructure and public health plans is crucial. Reducing carbon emissions addresses the root cause of instability. International agreements like the Paris Accord are vital. Science provides the knowledge to forge a better path. The polar vortex's stability is linked to our climate choices. Understanding this helps us prepare for future events. Let's explore how this affects our weather. The future is up to us, let's get to work.